Hello everyone, I'm Bhumi. I'm an Android software engineer at Meta for over a year now. I work in the video client infra team, and today I will be sharing our HDR story on Android so far. The agenda of my talk, I will be discussing why HDR on Android, what's our current approach to HDR, what are some of the challenges that we have faced, and what is our current solution. So why even bother about HDR on Android? Let's start with the basics. Why even have HDR? The one word is quality. High dynamic range, as compared to standard dynamic range, allows you to see more of the colors and details in the scenes. HDR is far superior and immersive to SDR in the following aspects. The first one is brightness. HDR is brighter than SDR. HDR brightness can be up to 10 times more than SDR. Next is color gamut. HDR is much richer in colors and adopts recommendation 2020, which is a much wider color gamut than recommendation 709 that is adopted by SDR. As we can also see in the images, the color range and the contrast range for HDR versus SDR is much higher. Next is color depth. With the increased contrast and colors, HDR also has more bits to represent values. HDR is generally 10-bit or 12-bit color depth, whereas SDR is only 8 bits. Hence, HDR has better transitions and gradient handling than SDR. So how about HDR on Android? Android is slowly adopting HDR. Samsung introduced HDR capture option in their native camera with their S21 and S22 flagship phones. This is available as an advanced recording option, and it's not the default capture option though. Google also now offers HDR support APIs to allow application developers for capture, transcode, and edit with Android 13. HDR uploads continue to increase in our Android family of apps, and hence it becomes crucial to handle the content correctly. So what should be the approach to HDR? The best way is to ingest as HDR. This might work for raw uploads. However, as soon as we need to apply any transcode or effects, there are additional dependencies with HDR processing. The first one is the dependency on HEVC or H.265, which is a higher standard codec. Stickers and effects in user-generated content are SDR, and they are often not compatible with HDR. There is also a player dependency on surface view for both preview and playback. We will also need extra storage to store in HDR as well as SDR for backward compatibility with old devices that will only play back in SDR. As we can see, each of these dependencies requires cycles to onboard and roll out reliably. Hence, the recommended and reliable approach for now is to Tonemap HDR to SDR on the Android client. Tonemap helps scale down HDR to SDR while attempting to preserve the appearance of the original HDR video, as compared to simply clipping the range, which will result in the washed out video. Once done correctly, the video is same as any other SDR videos, and we can use the same transcode and upload pipeline. Hence, we will also have compatibility with all the media composition and effects for the user-generated content. So what are some of the challenges that we faced with Tonemap? The biggest challenge on Android is its diverse ecosystem and lack of standardization for HDR in its early phases. For example, reading HDR content from properties like color format, we found out that it's not consistent for HDR videos on different Android devices. Hence, it becomes tricky to even use these properties to identify HDR videos. OEMs may capture HDR in different formats. So, for example, Samsung captures HDR in PQ, whereas Google Pixel captures HDR in HLG. Hence, we need to correctly read and tone map these profiles correctly. Incorrect or wrong profile tone map will make the video not watchable. There were some HDR support APIs that claimed to perform tone map. However, the behavior of such APIs was not consistent, and we found that on some of the devices, they will not do any tone map. Even if we can get such APIs to work, these APIs tone map at the file level that adds an extra latency and extra step to the pipeline. We ideally want to tone map at frame level and in real time. Lastly, we have limited tools on the client, and adding additional libraries will increase the app size, and there are license issues while using third-party libraries. Though Google provides more support for HDR in Android 13 and in the future, however, we had to solve this problem much earlier and come up with a native solution. So for our solution, we need to answer the following questions. Which videos to tone map? How to tone map? And when to tone map? So how to read HDR? The answer is color space. Now this is how various HDR technologies like HDR10 and HLG compare with SDR. Videos have the three following main properties that are useful to differentiate HDR videos: bit depth, color standard, and color transfer. Bit depth can sometimes overlap for SDR and HDR. Color standard is sometimes not reliable and can be read differently on devices. As seen, HDR10 and HLG have the same color standard. Hence, color transfer is the most useful property to determine HDR video. Next question is how to tone map HDR. And the answer is color conversion. HDR to SDR tone map is a tricky problem, and there is a color space conversion from BT 2020 to BT 709. As we can see in the graph, that these are nonlinear transfer functions. This helps keep more accuracy on darker values on the expense of brighter values. Hence, we need a transformation from nonlinear space to linear space first in order to apply any scale down of ranges. These conversion matrices are used from the tone map approach as described in ITUR. So the next question is when to tone map, and we have the following requirements. The first is that we have to apply some mathematical transformations. There should be no significant increase in app size, and we need to tone map at the decoded frame level and in near real time. So when to tone map HDR? And the answer is in the shader. So this is our upload pipeline. As we can see at the decoder, we have extracted the metadata to read the HDR properties, and we have the decoded frame. Here, we also come across the shader that receives the sampled values in YUV format. Hence, this is the perfect place to apply any mathematical transformations. Note that the tone map shader only has the math and is unaware of HDR versus SDR frames. Correct shader needs to be implemented and selected to handle SDR versus different HDR formats. After this, we can apply any other effects like stickers, etc. to the tone mapped SDR. And finally, this SDR we will preview or encode for the upload. So these are some of the results of our tone map. On the left, we can see the original PQ HDR video. In between, we can see that if we do not tone map we lose all the beautiful colors from the HDR. However, on the right, if we do tone map correctly, we can help preserve those colors. This is another set of results. This is again a PQ HDR original video. In between, you can see that if we do not tone map and apply the sticker is not compatible. However, when we do tone map and then apply the sticker is more compatible and the colors are preserved as well. This is a result from the HLG HDR tone map. And again, on the left, we can see the original video. In between, we have the no tone mapped version, which results in the washed out colors. And on the right, we can see the tone mapped versions where we have preserved the color. Lastly, comparing present versus the future. So at present, we tone map HDR to SDR. This helps keep videos compatible with our current pipeline and the video is not washed. In the future, we want to preserve HDR during transcode, upload, and playback. We will do this in phases as HDR evolves on Android and its dependencies are achieved. So in conclusion, I would like to say that HDR is gaining importance on Android. New devices are supporting HDR capture. Google also enables HDR APIs in Android 13. HDR ingestion is definitely our North Star, and HDR tone map is our current solution. Thank you, and looking forward to connect.